Okay, and this handling of the wiring goes beyond what we saw in the Investor Day video. The emphasis to go ahead and like, okay, we've got to start building a humanoid robot now to be able to fully automate everything because it's pretty clear industrial robots cannot do it. So if you're able to do harnessing and flexible things like that, that is pretty big. And I agree this idea that you need the simulation. And the reason you need the simulation is because you need millions of iterations, and you can't get millions of iterations in the real world without having like lots of bots and then lots of people working with them.
Hey guys, welcome to Connecting the Dots. A few days ago, I received an unexpected leak regarding Tesla's Optimus program. The leak contains several points regarding the status of the program, as well as a glimpse into the minds of those developing it. The leak was written, so don't expect to see any candid photos, and it describes the current state of development, so don't expect to hear fantastic stories of bots storming the factories or anything like that. What the leak does bring, however, is an up-to-date snapshot of the Optimus program, which, just like Tesla announcing its production numbers, helps pinpoint Tesla's progress among the sea of bearish and bullish expectations. To help me dissect the data and its importance for Tesla's future, I held a live stream with two prominent members of the Tesla community, Herbert and Dr. Scott Walker. Tesla Herbert is an entrepreneur who founded 3 startup companies. He's been a Tesla investor since the early days, and he currently hosts the Brighter with Herbert YouTube channel, where he interviews outstanding people and holds expert panels in an attempt to better understand Tesla, Elon, and the future they are building for us. His guests include people such as Monroe Life's Corey Steuben, Gary Black, James Dauma, Tesla boomer mom Alexandra Mertz, Dave Lee, Larry Goldberg, Dr. Know-It-All John Gibbs, James Stevenson, and of course Dr. Scott Walker. The list is endless, and if you want to get brighter, I fully recommend following his channel. Dr. Scott Walker is a robotics expert who co-founded 2 robotics companies. Originally revealed to the community on Dr. Know-It-All's channel, Scott's expert analysis made him one of the most sought-after guests on Tesla channels. Scott's unique insights on robots and on factories, and his dissecting of Optimus design considerations and of TeslaBot's way forward provide new understanding of Tesla's future. This video is an edited version of a live stream I had with Scott and Herbert, which unfortunately suffered from huge technical problems, possibly due to my CPU overheating. The points are revealed in growing order of importance, starting with trivial ones and growing into extremely hard to achieve capabilities. Now buckle up and get ready as we all peek into how Tesla is favorably disrupting the world we are living in. I received some unique info about the TeslaBot program, about Optimus, which gives me a pretty good picture of the state that Optimus is right now. I'll just share it with you in this live stream. My story with the TeslaBot started some time ago, when after the first AI Day 2021, a friend of mine who is a CTO of an AI company, she started to rant on her Facebook page saying something like, oh wow, everything is doomed. And from her aspect, it was, she runs an AI company, and she saw that after the first AI Day, Tesla will take all the exceptional AI talent. So I discussed the topic with her, we talked about it, and what she said was something like, Tesla will win AI and they will win AGI. And the reason is that all the top AI talent will want to work with Tesla, especially on the BOT project and so on. And she was right, eventually. We saw how the hiring grew and grew exponentially. And what happens also, she also said that Tesla will also win the BOT and probably also AGI. And she wrapped it up by saying that Tesla will become CHOAM, the largest company in the universe. And she went all in on Tesla. She sold stuff. She sold her car and just bought more and more stock. And later on, after the stock went tumbling down, I asked her, how are you right now? After losing all this money and so on, she said, I didn't lose anything. I'm still holding on for a long time. And the way she phrased it was that the car business and the energy business are like a safety net. But TeslaBot means that buying Tesla stock is like holding a call option on infinity because it can grow infinitely. And later on, still after the first AI Day, it was, I think, at the end of 2021, we had another call where she said that TeslaBot is a done deal. At that stage, she also had some internal information that she gathered, some industrial espionage or whatever. I don't know what, she didn't tell me. But basically, what she said there was something interesting. She said it was late 2021. She said that Tesla is planning to have the bot work at the factory this year. By the end of 2023, they'll have bots working at the factory. At that time, it sounded like science fiction. Nowadays, it doesn't seem that way, because all the discussions that I heard, like your interview, Herbert, your interview with Scott, you discussed the same thing, that the bot will be working in the factory this year. And this brings me to the leak that I received. It was, let's say, it was very surprising. First, let me just say that I haven't talked to my CTO friend for a while, and also her company fell apart. Basically, the other guys wanted to go to the short-term business, and she wanted the long-term business, which relates to the bot and so on, and they just disbanded. But regarding this leak, which came as a surprise, I'm not allowed to neither confirm nor deny whether it's from her or not, adding to the mystery. But basically, I just say I received this data, this info. I'm over 90% certain that it is true. It's not someone pulling my leg. And I have here a few questions that we can start with them. And the first question is, when will bots start working at the factory? And after, I guess I already ruined this as a question to ask you guys, but in your interview, you discussed that this year it should happen. And the answer to that is yes, it's confirmed. There are bots working in the factory right now. And this brings me to another question, which is how many bots are there? Any idea?
Well, I'm on the record for saying 500 by the end of the year. And well, we've seen probably 5 already together, and I think there were some other around. I'm going to say there's probably about 100 bots right now.
Yeah, I'd say about the same number. Yeah, because there was 6, and it's going to be exponential. So I think it's about 100. Yeah, I like that.
Okay, let's put it this way. I don't have a number, but let's say 6 is a few, right? How much is several?
10 to 20, several. Yeah.
What I have is that there are many bots. The news I got that there are many bots, but only some of them are on the factory floor. Most of them are in the research center. And basically, they said seeing them walking at night is pretty spooky. But, it's interesting. Now, this brings me to even more interesting questions. What kinds of work are they doing in the factory?
I'm assuming they're probably doing part loading and unloading.
I think I'll show right now what you said, Scott.
In August of last year, put together a little animation that's called feeding the cookies at the robot zoo, showing the kind of applications that humans are doing it already. And it's so simple. It's like, it was very clear to me that the bot could do it. And we know there are going to be others. So we got very low hanging fruit, and we have others that are going up there. And then sure enough, 2 months later, what does Elon say? He says, what are they going to do? And he said, we're going to start Optimus with very simple tasks in the factory, loading a part into one of our more conventional robot cells that welds the body together. So it's exactly what that little animation is. And then later we get that glimpse. So there it is. So there's an example of that could be a human, or that could be Optimus just picking up very simple parts, bringing them in, dropping them off where they need to be. You don't need high precision because you drop it in there. It kind of fits in exactly the way it's supposed to. You make sure you get the right number of parts. You put them in the correct order. You walk away, you hit a button, and then the traditional robots do the welding task, exactly like Elon sort of outlined right there. And then I think the same time, just before Investor Day, there was a video that came out of Shanghai, China, showing what it looks like in there. And sure enough, you can see an actual operator doing something very similar to that. And you can see that's very simple. It would not be hard to do. And so
let me go ahead and play that, and you talk to it while we're playing it.
Exactly.
Okay,
exactly. So in this case, we have one operator whose task is actually to load small parts, very small pieces of sheet metal that have come out of the stamping presses that are part of the underbody. He has to wait when it's right. He gets the indication, picks up like a left hand and a right hand side, brings it on over, drops it into a fixture where it will just kind of fall right down in the correct place. And now the yellow robot can go over and pick it up and actually put it into its final destination. We see the same things happening here. And he was a bit trigger happy there. He walked in too quick. He ended up triggering a safety that stopped it. But now he's going to go in and put two larger pieces of sheet metal in there that are very light and very easy to manipulate. And you see, really not a hard task.
Yes.
So that was our prediction, that it would be something like that. That's what I refer to as the low-hanging fruit that's hanging so low it's on the floor rotting. It's just that easy to do. So that's why my expectation was you do something like that. Very low precision. Your speed does not have to be that rapid. However, you are picking parts always from a random position. So it's not as easy as having an industrial robot just always picking up the parts. You need something that needs a vision system that can cue in, go in, kind of grab the part roughly in the right place, bring it on over, drop it in the right place, push the button and go. And continue that cycle, 1-2 times a minute. That's it.
Seems very, very doable, right? Because it's just a short distance. We're not talking about traveling across the factory floor, just standing from this location, moving 4 feet here, moving back and forth, maybe nobody around us. It's very doable, right?
Yes. Yes. And the other thing is, how much do you think that operation cost Tesla per year?
Mm-hmm. An employee is probably $100,000. It shouldn't be that expensive. This is but
depending on the number of shifts,
benefits. Yeah.
If you're going up to 4 shifts, it could be close to $250,000. If you're running 4 shifts.
Yeah. So basically, your prediction was confirmed. What I was told, basically, they didn't say that this is what they are doing. What they said was something else, and what I heard was something a bit different. And but you can deduce from that you were right, because what they said is basically that the bots are already doing simple jobs in the Fremont factory. Now, simple jobs, you can interpret it in many ways. However, the next sentence is what gave things away. They said they are aiming now to get the bots to the stage where they don't have to be told when to restock certain items, and they can work it out for themselves. And the way I say it, this is what gave that you're right. Basically, was if they are trying to get the bot right now to see for itself when it has to restock items, then it's doing what you said.
Yeah. Okay.
Can you hear me?
Yes. I'm writing that down. So yeah. Yes. So it's already doing simple jobs in Fremont, and simple jobs can be almost like the first one that they showed us with Bumblebee, unloading that one machine and putting it over to another. So that's one example. The other is, of course, like feeding the KUKAs, as we talked about, by just loading in small pieces of sheet metal. But they're coming out of some sort of dunnage where everything is in there. It's piled in. So you take it from the top and you keep on going down further and further until you run out of parts. And of course, what you want to do is you don't want to run out of parts and then ask for new parts. When you get low, you then want to make the request, say, hey, guess what? I'm going to be running out pretty soon. Can you bring the next batch in ahead of time? And the question is whether that's being done the traditional way, whether some humans are then driving a forklift around, or whether the bots are somehow being involved in that restocking operation. I would suspect right now it might be that the robots or the bots are indicating to whatever is the current system to go ahead and bring in some more dunnage or to swap it out. So I might assume that's still humans driving the forklifts, but you never know. I'm assuming.
I doubt that, Scott.
Yep.
I think it might be like when it's empty, they press a button and then it, this thing fills it all up again. Then they do it.
Could
and
be.
When it's empty,
Could
they
be.
press a
Because
button.
in some cases, what you have is that you will have like what they call a gravity feed conveyor, where you'll have these small totes with small articles that are in there. And when you finally run out of it, what you have to do is you have to take that tote out and you put it in a return tray, and the next one comes down with the operations. And then someone will then come around to the back end of that feeder and then take all the empty totes and go back and then restock them, and then they come in. But that's usually done through a completely different mechanism. So as far as the operator is concerned, they're pulling from something. When that thing is empty, they might have to then take the tote, put it somewhere else, get the next one, and then start doing the feeding. So that could be what they're talking about.
Hey, Dots, can I address this comment that this person put on? So this person, Justin, said, nothing burger. We could have easily guessed this was the case. No big reveal from mine. Yeah, let me. I do need to address that because that's not true, Justin. I don't know how many people have kept saying bots is not going to happen in my lifetime. Then they started saying it's not going to happen for many years. Yes, I see that, you just saw a demo. This thing that Scott said, that this bot is here this year, the fact that it's probably already working in a factory now, how many people, 90% of people would have said, you're crazy, you're being a Super Bowl optimist. The fact that there's confirmation, now this is a rumor still, not until we get true confirmation, that if this is true, that a bot is actually today working, this is a big deal. It's not a given. It's not a given that this bot is already working today. And what Scott and I have been saying is that bots are much easier to make, and that it can be a very, very specific point-to-point, very specific job that it's doing, like Dots is confirming here. There's just a simple thing. We're grabbing one item, putting it in another. You could do that now. It's a big deal for Tesla, the business, Tesla, the stock. And I don't know how many, 90% of people would have told us that's not happening today. And what we've just confirmed is, maybe confirmed it is.
Yes, I agree. And it's sort of playing out the way we were expecting it, which is what gives me a lot of hope that maybe they're even a little bit ahead of schedule of some of the expectations. But a lot of this, they already told us. There is Elon's quote pretty much saying that it's going to be used to do the traditional task of feeding parts to the traditional welding robots, which is, I kind of guessed that ahead of time. And then it turned out that's what Elon said to prove that. But then Milan also came out and said that they were going to start taking the bots and then looking at the task on the floor and start training them for that. And he said that back in September of last year. So we already know that they're doing that. We've already seen the examples of them showing us the demos, like in Investor Day, of the robot helping to assemble the other robot. So we know that they are functioning, they're going around, they're able to demonstrate that. And it seemed to me the next logical thing is they're going to be actually going out on the floor and they're going to be doing testing. And when they say it looks kind of freaky seeing them walking around at night, well, that's because they are trying to put as much of a lid on this as possible. So it's nice to finally hear this, because they have been so good on the leaks on not letting us know anything on what's going on. And that's rather remarkable. And the only way you can do it is that maybe you're doing it on the odd shifts when there's no one else around, when there's no one that's part of the team that would be able to go in and take a look at it. So the closest you might have is that someone observes something and is able to sort of spill the beans that, yeah, I saw something. But we haven't seen any video yet, probably because they make sure that no one's going in there with any sort of video recording apparatus. And if there is, it's only approved people, and they're just doing it for the research purposes, and that's it. So I think a lot of Tesla employees are pretty good at being tight-lipped when they really, really need to be. So that's probably why we haven't heard very much. But hearing this is confirmation that they're kind of on schedule. They're testing it out, which means I think by the end of the year they'll have that. Now, are they going to be putting it on the Cybertruck line? I don't think so yet. My expectation, of course, when I heard that they're working somewhere, that's like, it's got to be in Fremont. So of course it's going to be there at first. Eventually, yeah, it'll probably make it on down there, but I don't think the Cybertruck ramp is somehow linked to having Optimus up and ready. Okay, in Mexico, that's a different story, but the Cybertruck, at least not yet.
So, Dots, you said that earlier you said you're 90% sure that this is true. Can you give us a little bit more, because it is true that this is still very much hearsay.
Okay, now
I have a friend who told me, but is there more than that gives you 90% confidence this is
over
true?
90. Let's say it's from someone that I trust, not a kid or a troll, someone who's older. I trust them, and the way they framed it, from how they got the data and so on, was very fitting. Everything matches. Let's say, maybe they fooled me, but I'm pretty sure that's not the case. I'm over 90% certain that it's true. Basically, if I had to put money right now on a bet, then I'd easily put it over 90% sure. I don't know if you notice, I'm going through the points that I received, not by the order that I received them, But by gradually they're growing. I mean, I'm keeping the good stuff for the end, basically, because there was something there that just when I read it, I was just wow. And again, this was the only thought that I have. It was amazing. I was just knocked off my feet. And it was so big that later on, what we talked till now, I only realized that this data was valuable also only when I reread the messages the next day. And so in a moment, I'll get to more important stuff. I mean, more spicy stuff. And you had a question, Herbert?
I was just going to say that if you heard something from somebody, how do we know that you interpreted it correctly? Like, how do you know for sure that this is actually working in the in an actual working environment already versus they're testing it?
Oh, basically, I'm pretty sure that they're testing it right now. I mean, if they have to if they are now getting to the point where they want the bot to start realizing when it has to restock, then it's not actually productive work yet, because you have to manually take care of the bot, manually check the bot and tell it when to restock. But the way Tesla is organized, the way their production line or metrics is built, we learned that from Joe Justice, is that they have these production cells, which means they can, I'm not saying this is the case, but they can very well have the production line just going on, just working, with the bot working in another cell, and just when it does things right, only then the output goes forward, and it doesn't stop the main flow through the main line. But right now, basically, it is the way I see it. It's still studying, but I'm pretty sure, from what I'll show later on, I'm very sure that this year it will be working on the easy stuff, because it's already doing a lot more difficult stuff. And this brings me to something that the bot doesn't do, but it was interesting that it was in the message. They wrote me something that at first I seemed a bit incredulous. I mean, this is the thing that detracted from my level of belief, which means they said that a few months back, there was serious debate, I'm quoting now, serious debate within the bot team as to whether they should teach the bot to do, now I'm using my words, to do something like Atlas-style gymnastics and so on, like something like what the Boston Dynamics Atlas does. So they had to debate whether to just focus on productive work or also do all these party tricks and so on. Now, the way I saw it in the beginning, I saw, okay, this isn't real, because basically, just like Elon said, the bot is supposed to do labor, so on. But then I thought about it and said, okay, the guys that I know, guys who work in AI, I know young guys, so on. I work with them, and one of the things that happens is when you work at this stuff, you want to do exciting stuff, exciting things, and I just realized, okay, if the mechanics support such tricks, I mean, whatever the bot body can do, then everything else is doable. And just before explaining, I just said that when I talked to my CTO friend over a year ago, he said something about Tesla, that the reason that Tesla will win is not only that they have the best AI people, but also because they are led by someone who is laser focused, meaning Elon. And the way I see it is that the AI guys wanted to do more exciting stuff, and Elon always focuses them on the main target, which is let's do a robot that can do productive work. And I just want to ask you, Scott, a question about this. During your conversation with Herbert, you discussed about Atlas, the Boston Dynamics Atlas, and said that it's basically impressive. The things that it can do, the stability and so on, the backflips and so on. And when I saw that, let's say at this point, I mean, you're far more of an expert than I am. But on this specific point, I humbly disagree. And I want to hear your opinion. And the reason is, I worked in the past. I used to lead a group that did simulations, which means we produced an engine for making simulations, some kind of framework for building large-scale simulations. And we built large simulations of very complex systems of systems with lots of internal systems moving and so on, with all the physics and dynamics and mechanics. This was before the AI era, but I know how simulations work, basically. You represent the body, in this case, it's the bot. You represent the mechanics of all the gimbals and so on. And what happens later on is that just that you running through the simulation, you check it compared to the body itself, to the bot itself, and you fine-tune the simulation. And once you have a good simulation, you're good to go. And I want to show here something that both of you know. I don't know how many of the viewers know. Many probably do. But basically, there's something that was done by OpenAI. Let's just share it for a moment, on how to teach both bots to play hide and seek, a multi-agent hide and seek.
These agents are playing hide and seek.
Just show the clip.
These agents have just begun learning, but they've already learned to chase and run away. This is a hard world for a hider who has only learned to flee. However, after training in millions of rounds of hide and seek, the hiders find a solution. The hiders learn to use rudimentary tools to their advantage. By grabbing and locking these blocks, they can create their own shelter. The seekers are locked in place for a brief period at the start of the game, giving hiders a chance to prepare. Even so, the hiders must learn to collaborate, accomplishing tasks that would be impossible for any single individual. The hiders are not the only ones who can learn to use tools. After many generations of failing to break into the shelter, the seekers learn to jump over obstacles using ramps. However, after many millions of rounds of having their shelter breached, the hiders learn to take away the primary tool the seekers have at their disposal. Note that we did not explicitly incentivize any of these behaviors. As each team learns a new skill, it implicitly changes the challenges the other team faces, creating a new pressure to adapt. We've also put these agents into a more open-ended environment, randomizing the objects, team sizes, and walls. In this world, they learn to construct their own shelter from scratch, requiring that they arrange multiple objects into precise structures. To prevent seekers from using the ramps, the hiders move them to the edge of the play area and lock them in place. We originally believed this would be the final strategy that the agents learn. However, we found that after more training, the seekers discovered that they can jump on top of boxes and surf them to the hider's shelter. In the last stage of emergent strategy that we observe, the hiders learn to lock as many boxes as they can before constructing their fort in order to defend against box surfing. So how do agents acquire these skills? They're trained using reinforcement learning, an algorithm inspired by the way animals on Earth learn. The agents play thousands of rounds of hide and seek in parallel for many days. They train against each other as well as past versions of themselves using an algorithm called self-play. Co-evolution and competition on Earth led to the only generally intelligent species known to date, humans. While this world is far less complex than Earth, we have found evidence that simple rules can lead to increasingly intelligent behavior from multi-agent interaction.
Wow.
Basically, in December 21, in the video that I did about TeslaBot is a done deal, my friend just told me, she said, okay, the bots can learn everything. And she told me, just think for yourself, how can they learn things? And you get bonus points if you don't involve humans. Because the first thing I want to say is just a human does things and the bot mimics the human. As we saw also in Tesla's videos with the guy that does things and the bot mimics it. But she told me, don't do it with humans. I thought, okay. I said, okay, reinforcement learning, just like we saw here, it's just like teaching a rat to push a pedal and so on. At first, when it goes to the side of the box where there's a pedal, you give it some food and so on. And then later on, when it goes to the pedal itself, you give it food. And when it presses it, you give it even better food and so on. And the same thing happens here. So you just build a simulation that mimics the true physical, mechanical behavior of the bot and the true physics. And you run it millions of times. And you don't even have to tell the bot what or how you want to do. You just reinforce the right behavior and it learns. And this way, we also saw it also in Tesla later on, when they showed it also, I think in AI Day 2, where the bots learned how to walk through simulation. So the way I see it is Atlas, Boston Dynamics Atlas is very impressive for programming a bot
Mhm.
to do these actions. But once you have AI and reinforcement learning, then all this is easy. Do you agree?
Yeah, yeah, I absolutely agree, and that's
Okay. So basically, when they talked about the thought of doing these party tricks and so on, it's not out of the question because basically, whatever the structure and mechanics of the bot can support, then I'm a bit simplifying it, but whatever the structures and mechanics can support, it's pretty easy to teach the bot to do this. You just run the simulations and then you let the bot do it and improve. And the guys developing it, they're the best AI guys in the world. And they're very competitive. And they want to do fun stuff. And they see that Boston Dynamics has all the limelight and so on with the bots doing party tricks and somersaults or whatever. And they want to do the same. So they say, hey, it's pretty easy. If the bot can do this, why don't we let it learn this? But of course, there's always what my friend said. My CDO friend said that the reason that Tesla will win AI and the bot, and probably also AGI, is not only that they have the best AI guys in the world, but also that they have a leader that is laser focused on a mission, which means he will point all the vectors to the right direction. So the AI guys want to do these tricks, but Elon says, yeah, you can do it. It won't take too much time, but we don't have the time to do that. Just go on and we have to work straight ahead to our goal, which is to win labor, to have the bot free mankind from human labor. So it's easy to do what Boston Dynamics does. It was very hard in the past, but now it's easy. And the reason they're not doing that, I don't mean backflips, but other party tricks. The reason they're not doing that is that they have one goal, one mission, which is freeing humanity from human labor, from the need to do human labor. Okay, I'll go on to the final point that I had. Basically, it's what's the current status of the program. The most important thing, I think, that Optimus can do. In that video with my CTO friend, the specific example he asked me was, what she wanted me to teach the bot was how to thread wiring through a car, which means to plug a connector at one end and to thread the wiring through the car and connect it to the other end. And the bottom line is once you let the simulations work, you can even reach very weird solutions that humans can't do, like two bots lying inside the car and another bot throws them the cable and each of them stick the plug inside and they thread the wire and so on, or whatever. There are lots of situations, lots of possibilities that the simulation can optimize. So I asked about wiring, and they said that they are able to handle wiring. It was unclear to them whether they can actually install the wiring looms into the car. Of course, I don't think they can, but they are able to handle wiring. And as far as I know, this is a real problem for robots because wires dangle, they move all the time. So you have to recognize them, which is done through the vision system, and you have to catch them at the right time. So what I was told that they are able to handle wiring. They didn't, one who told me didn't know whether they can thread it and so on. But that by itself, knowing that they can handle wiring for me, which was huge news.
okay. And this handling of the wiring goes beyond what we saw in the Investor Day video.
Correct me if I'm mistaken, but this is something big. I mean, it's something that normally it should be difficult for robots to do.
Yes, robots do not like dealing with flexible material. Elon found that out the hard way with the ramp up. Yeah, the Model 3 ramp up had a problem with flexible robots, and him understanding that your parts have to be rigid, their locations have to be rigid in order for the standard robots to be able to do that. That might have been, let's say, maybe not the kernel of the idea, but maybe the emphasis to go ahead and like, okay, we've got to start building a humanoid robot now to be able to fully automate everything because it's pretty clear industrial robots cannot do it. So if you're able to do harnessing and flexible things like that, that is pretty big. And I agree this idea that you need the simulation. And the reason you need the simulation is because you need millions of iterations, and you can't get millions of iterations in the real world without having like lots of bots and then lots of people working with them. So what that does is it gets you a good guess at what you want that neural network to look like, because your physics is kind of close to reality. Then you've got to turn it loose in the real world to fine tune it to reality. And OpenAI has already done that with the Rubik's Cube robot. So they did that. They did millions and millions of simulations to figure out how to get a hand to work the Rubik's Cube. But what shocked them was when they put it into reality and started doing it, that suddenly these emergent behaviors came out that they did not expect, because it started learning new things as it started to understand real world physics. So I would think the same thing would happen with a bot, that if you are getting these simulations showing how to start manipulating wiring and everything else that's going on there, it'll give you a pretty good guess. And then you go out in the real world and it won't do a very good job at first, but then you start doing it again and again and again, which is why when you said that they have many robots, some are on the floor and some in R&D. What I'm picturing is that, they are testing it out on the floor in different areas to make sure it's able to do these simple tasks and that it really is doing it, and trying to get data on that. The other half is that we've been running these simulations of some really challenging things, and we've got it up to a certain point right now. And now we've got this room full of bots, and all they're doing is they're going over and repeatedly doing the same thing again and again and again and again to get that last data to tune them in. So that's why I was not surprised to hear that. It's like, yeah, of course, most of them are going to be there, because that's where the fine tuning of those neural nets is going. But you need the real world data. That's why FSD is on the streets. The simulators are good for you being able to go through some nasty situations here and there to understand what's going on. But the reality is you have to collect the data from the real world. And that means you need lots of bots. I mean, you can either do one bot and run that bot for 1 million years, or you can get 1 million bots and run them for 1 year to get the same amount of data. So the more bots you can get, the quicker you can train it. And of course, virtual bots are very easy. That's just simple copy and paste and do that. But it gets you 80% of the way there, maybe 90%. That last 10% is where 90% of the effort is.
Scott, I know you've seen his video from Ashok that he did a presentation 3 weeks ago, and he showed that just the videos alone, they're able to do a recreation of the 3D space to be able to actually then manipulate it and make decisions and run these massive simulations. So today, I don't know if you need 1,000 bots. You can just have 5 bots going through the exact same location, running these simulations now, and deciding how to teach it what to do. You know what I mean? Like, I think the simulations or the real world things would be just to really test to see how the bot moves and if it's actually interacting with the real world. But the actual decision and what to do and how to do it, that's what I got from listening to Ashok's presentation.
Yes, it can do a lot. What I'm thinking is when it comes down to the dexterity that you need with the hands, is that there's just going to be something. There's going to be some slippage. The same thing with walking. Is they're able to do a certain amount of walking in the simulation, and then you get out to the real world, and the hardness of the floor is a bit different. The friction's a little bit different. There, all these little other things. And that's why I'm saying is that you get really close, and then you're going to go through there. And if we back up for a second, when they were talking about this discussion about wanting to do more Boston Dynamics kind of things, I've always felt that some of those servos were overpowered. I was like, why are they so big? You don't really need that much. It seems like they have a lot of excess torque. And of course, they did show us that one video of it coming down and not breaking the leg, which tells you they have incredible torque control. So I'm not surprised. They probably said, you know what, we can probably start to do something now. I don't know if that means literally it can do backflips, but maybe they're starting to do cartwheels. It's like, I remember that when you started on gymnastics, that's like you kind of started with that at first. The other thing, what it might mean to me is they've probably got the full unlock now going with the pelvis. So that means their walking must be much better. If they're getting a discussion about, oh, we should be able to do that, that means they are really walking confidently. And maybe they're not walking, they might be running, because you kind of need something to be able to do that. And you can see, Atlas is be able to do that as well. So where they draw the line on what is gymnastics, I don't know. Is it balance beam kind of stuff without doing the flips? Just jumping up and off of stuff, being able to race upstairs? What is it? But it probably means that they're starting to get that walking motion. And when they tested it in reality, it's picked it up a lot quicker than maybe they expected.
Also want to make a point about the wiring, the harness. If that's true, that the TeslaBot can actually handle wiring, that's a huge step change, because thousands of bots out there today can carry boxes and move boxes, and they don't have hands. Scott and I looked at 10 different bot companies out there, and only 1 or 2 actually have the digits, the fingers. And so the ability to grab a wire, if it's dangling, and then be able to plug it in, that's a huge step change. Even Tesla's own video,
Yes.
Scott pointed out in the past that it was just, they stopped it from showing you that it actually plugged it in because it probably couldn't at that time to do that. If that's true, this is no other bot has been able to do something like this. You're talking hands, talking ability to hold the wire, grabbing it and putting it somewhere else. Every other bot out there don't even have hands, or even if they do, there's no way they can do something like this. So
Yeah. And part of it has been the question of what do you need to put into the hands to get the dexterity that you need? Do you need a touch sensing? Do you need all of that? Because I have a certain amount of feedback that's just the force feedback that's coming from closing the fingers down. What I think the trick really is, it's the vision system. And it's sort of like what Dots was talking about, is that they're probably looking at the wiring. So without the cameras, it's not going to work at all. But once you get the cameras in there and you get enough training data on that, it's looking at that and it's understanding the flexibility based on what it sees, not necessarily the physics or the feedback or anything else. So we can do an awful lot of things just with our sight alone. Of course, what amazes us is sometimes we can close our eyes and our other senses will take over, and suddenly we're more tactile when it comes to doing something. But a lot of times we're not that tactile. It's just all vision driven to get us to where we have to be. It's only when we close our eyes that we suddenly realize, oh, I've got to rely on a completely different set of inputs to be able to solve the problem.
but Scott,
So they know what they're doing with vision.
I don't know. I mean, like, okay, sorry, not that you're the expert here, but remember that video that we saw of the knee and the egg? There was no vision there. It was just going down, and then they put the egg,
feedback.
and then it immediately stopped. It didn't have cameras on that leg. I didn't see. So,
Right.
you know what I mean?
So now you combine the two. So what we're talking about is that what they were doing is they were sensing as they were pushing towards something, they were getting a requirement, a force or torque requirement that was beyond what they expected at that moment, which told them it's time to stop. And that's what you can do, you know, the classic thing with closing your fingers on here. As soon as I feel resistance on the motor drives, I know I must be clasping it. So I can do that with my eyes closed. However, I get a super benefit if I do it with my eyes there, because then I know, oh, now I need to slow down because I'm kind of getting close. So
Gotcha.
It's true that they have that, but what it means is they don't need to have touch sensing. That's always been the question, is what kind of additional sensing? And everyone's tried to over-engineer the problem by saying, well, we need some motors to be able to close everything. And then we're going to have to put in all this other stuff to be able to get touch sensing and everything else. And you end up over-engineering the whole thing because everyone says you need this, you need that, you need something else. What they're saying is minimalist, absolute minimum. What do we need? We've got eyes and we've got the feedback coming from our control system. Is that enough? That's what they're trying to find out. And my suspicion is they found out that they can do it. And they may find out that there's other, quote, noise that they're coming back within the system that turns out to not be noise, but is another kind of signal to tell you what's going on. So there could be like other vibrations that are felt through the system that you were able to pick up elsewhere to give you an idea. It's like, when I get that kind of feeling or that vibration, it's telling me this is happening and that my output now needs to be this to react to that. So, I mean, you know, the whole thing about the animals knowing when the earthquakes come before we do, because they just get this other kind of feeling of something is out there. It's probably almost the same thing, is that it's not just what I see, it's not just what I feel, but there's some other third sense that they are probably able to pick up.
Okay. A big shocker if it can do wires, but in the future, it needs to be able to do the fluff.
Yeah, the fluffer. But that part's not needed, it turns out.
Okay, before going on, just I'd like to say thank you to the guys who gave the super chats, Steven, Oscar, Mike, Rebellionaire. Thank you guys, I appreciate it. And I'd like to, before we go to some questions, or if people have, I just want to show the impact that this has on Tesla. I'm taking this also from the video I did with my friend. I mean, it's not my points, basically, it's hers. Once from a long time ago. She thought about it a long time ago. One moment, let me just check it. I'm not going to show the video itself, just I'm going to show these points here. And let's say a bot replaces an employee. So a bot is worth one employee, one salary. But if you do it 3 shifts a day, then it's 3 employees. but the bot can work 7 days a week, not 5 or 6, depending on if it's China or in the West. So it's either a 4.2 or 3.5 salaries. Let's say it's 4, for example. Now there are things that we don't take into account in this calculation. Let's say basic salary, I don't know how much it is, but 4 salaries of a line worker. And it can be basically in any job later on. So we have 4 salaries, but if the bot works twice as fast, and it's possible because the bot doesn't get tired, if it does the things as fast as a human can do, but it doesn't get tired and just goes on working and working and working, then it can be, if it's 8 salaries, or if it's 3 times as fast, it's 12 salaries and so on. You don't need to pay for vacation. There's no sick leave. There are no quality problems like when they come to work drunk or hungover or tired. They don't get tired during the work. So the quality is always spot on. No unexpected leave, no health care, no workers suing their employer and so on. You don't need catering, lunch break, toilet break, and so on. And something else also, you don't need the workplace safety, which means it's okay if there's a lot of noise. It's okay if there are gases. It's okay to go. You already said that in your interviews, that it's okay to go and work along with the industrial robots, the KUKAs and so on. So you can do a lot more things. And I think the bottom line here is that the factories can, if you look at factories nowadays, the production lines in car factories, they progress at the same rate as they did over 100 years ago at the time of Henry Ford. And the reason is that all the machinery got better and improved, and things can go faster. There are robots and so on. But one thing didn't change, which is the capability of humans to work. If you work beyond a certain pace, then you'll get quality problems, you'll get tired, there are safety risks, and so on. And the bot doesn't have all these. So you can just crank things up to the highest possible speed. And this is what Elon imagined when he talked all the time about the alien dreadnought, which means you have a factory filled with industrial robots and lots of humanoid robots, just churning out cars, spitting out cars as fast as possible. And if you look at this, you see, just take all the salaries of all the workers that assemble cars for Tesla and say that every 8 of them or whatever are by one bot that costs $10,000, $20,000. It's a huge saving. It's unbelievable. And just like you said, I don't see Tesla selling the bots for a long time, because they'll first use them in their factories and suppliers and the main sister companies such as SpaceX and so on, and the Mars mission and so on. But also after that, when they do start selling factory bots, they're still not the AGI bots. I don't think they'll sell them, because basically
They don't need to sell them.
they will become the world's largest labor supplier company, which means like nowadays we have manpower companies. Yeah, they can just list them, they just as a service. Because right now, you don't own, if you have a factory, you don't own your workers. You pay them a salary. And I think every factory owner, every company will gladly replace the workers with bots that as long as the price is right, and just pay the salary every month, software as a service. And it's a huge saving and a huge bonanza for Tesla.
Yes.
Yeah, this sheet is pretty much in line with what we've discussed in the past, Herbert.
Mhm.
As far as the savings, we were way more conservative. We were way more conservative on the capability of the bots. Instead of saying that they were twice as fast, we said they were like about half the speed. So maybe they replaced half a worker or something like. And even then, you can come to a very rapid return on investment. You can easily show, with the most conservative of estimates, that you can save 50% in your labor costs. Very conservatively. But if you actually start looking at the robot having more and more capability, and the number of shifts you put in there, it's incredible. You start saving 70-80% on your overall costs.
Mhm.
So I already see that within the first year that if Tesla is putting it in there, they're already saving enough money to pay for the program. So they'll be break even really, really quickly within the first year once they start getting it in there. And as it starts to improve, then they're going to start making a lot more money on there, and you're going to start seeing it on the margins. The margins will really take off at that point. So it's good news to hear they're already doing that.
Do you really think that a bot can work 24 hours a day for 7 days a week? Doesn't it need to have, maintenance, repair?
Yeah. Yeah, it does. So you have what I think is it 168 hours in a week? And when you're doing 4 shifts, you're talking 160 hours, right around there. So that means you've got 8 hours of downtime. Well, that's like roughly an hour per day that you can be used for charging the bot if you want, or doing preventive maintenance. But the main thing is, I have a need for 10 bots to do this particular task 24/7. Okay, buy 12. All right. So what you do is that, you just swap one of them out and it goes over to either get charged or something like that. So there's just been discussion. Are they going to have a swappable battery pack? And it's like, they're not going to have a swappable battery pack because it's complexity, it's cost, it's mass, and everything else. The bot is the swappable battery pack. That's the point I want to make.
They just bought Wi-Fi. They can do inductive charging just standing there.
They could.
Oh,
yeah, they could at some point if they want the extra mass. But even before that, the whole idea is that you just
it's
add
not a
one
big
more
mass.
pod in there.
It's
mass.
very tiny. It's very, very tiny.
Yes.
Wi-Fi's model is very small. It's already being used today for these industrial robots, these what do you call mobile robots in the factories? It's already being done. So
right, for the charging. Now, of course, when you're recharging, you want to have more power to come in to be able to charge everything up. But when you're actually running it, then you don't need that much. So bot is going to be between 100 and 500 watts. So I would think you could probably do that wirelessly for a continuous operation, as opposed to having to have a battery pack recharged.
Let's see if there are any questions here before we wrap things up. When we're reaching the hour. Larry, I saw that you asked a question, and just see what the question is. Rate of production of the bots right now. We don't know that. I don't know. I think you arrived after the beginning, but what the leak that I heard said basically was, they didn't give me a rate, but they did say that there are many bots, but only a few of them are in the factory, and that they can they are doing simple tasks such as stacking the machines and so on. They're right now working on the bot, realizing on when it should stack the machine, or when that part has been taken and it should fit a new part. They're working on that now, and that the bot can also handle wires, which is a pretty hard task. That's most of the things that were said here. I don't see any questions, so really thank you very much, guys. I really enjoyed it.
That was great. Thank you.
Yeah, thank you too.
Guys, it's been a pleasure. Thank you very much for coming on my show. I really appreciate it. It means a lot. I love your channel, Herbert.
Thank you.
Really one of the best
you.
ones
I
around.
love connecting the dots.
And Scott, your insights are amazing. So
thank you.
I learned a lot from both of you. So thanks, guys. I really enjoyed it. And thank all of you who stayed and watched the show. If you like this video, please smash the like button and subscribe. This really helps me reach more people. Also consider supporting me on Patreon for as low as $1 a month. Patrons are what make this channel possible. So thank you all. Also, I'm about to prepare a Q&A video. So follow me on Twitter, and under my pinned tweet, you'll find the link where you can post any questions you might have, and I will do my best to answer. I hope you enjoyed this discussion. Let me know in the comments below. And until next time, I am connecting the dots, and you are amazing.
Twitter is becoming the place to be, so I invite you to follow me there. I'm Connecting No Dots. I tweet several times a day with everything from long threads analyzing Tesla matters to making memes and hanging out with you guys. So, see you there. Until next time, I am connecting the dots, and you are amazing.